All right, 3-5 proportional and non-proportional relationships. Not like boyfriend-girlfriend, like X and Y. Let's go! Inductive reasoning is using a pattern to find a general rule. So we're going to see a pattern, and we're going to try to find a general rule of, does it go up 2, does it go down 3, is it a straight line? We're using a pattern to figure out whatever that rule is. So what that would look like in a homework assignment is it would be like this. The table here shows the number of miles driven for each hour of driving. So if I drive 1 hour, I go 50 miles. In 2 hours, I go 100 miles. In 3 hours, 150, and so on. Whoa, except for that last one there. Graph the data. What conclusion can you make about the relationship between the number of hours driving and the number of miles driven, M? Well, the graph shows a linear relationship, except they made a mistake. 4 here is supposed to be 200, according to this graph. The graph shows a linear relationship between the number of hours and the number of miles driven. So that would be our conclusion. All we can really say is it is linear, is all we can say for now. Then they're going to say write an equation to describe that relationship. So we look at the relationship between the domain and range. So as it goes up 1, it goes up 50 more. So it goes up 1, it goes up 50, it goes up 1. Hey, they fixed it here. So since this is a linear relationship, the ratio of the range values and the domain is a constant. That's important. The difference for the values of h is 1, and the difference for the values of m is 50, which is what we've said here. So that suggests that m equals 50h. So every time we go up, the miles is going to equal whatever is times 50. So we're going to try substituting them in to double check and make sure that's right. So we put in h, or put in 1 for h, comes out to 50. Put 2 in, comes out to 100. 3 comes out to 150, 4 comes to 200. It seems like that works, so I can say that the equation function of h, because we're doing this, remember they asked for a function, not a y equals. Here, when they said, let's see, check, so they want this in a function notation. Since the relationship is also a function, we can write the equation as function of h equals 50h instead of y equals 50h, or m equals 50h, where h represents the number of miles driven. Function of h is the miles driven. All right, try this on your own and go. Okay, well, when I look at this, there's a graph this in a table, so hopefully there's a graph in your notes. So graph that. What conclusions can you make about the relationship of miles walked? Well, if I just kind of halfway do this, we go 1, 2, 3, 4. Let's go 1, 2, 3, 4, 5, 6, 7. If I go over 1, I go up 1.5. If I go over 2, I go to 3. If I go over here, it goes to 4.5 and goes up to 6. That looks, I know it's not a great line, but that looks like a straight line. So I'd say that this is a linear relationship between the number of miles spent walking and, so yeah, linear relationship between the number of miles walked and the time spent walking. All right, write an equation, pause this out, give it a shot. All right, write an equation based on the relationship between hours and miles walked. All right, so if I look at this, this is going to go 1.5. This is going to go up 1, 1.5, and 1, 1.5, and 1. So it goes up 1.5 every time. So I would guess right off the bat that it's going to be 1.5h, but I probably should double check. So we'll actually put a couple in here. So 1.5 times 1 equals 1.5. I'm just going to, for fun, jump ahead here. So let's go 1.5, 4. 1 times 5 equals 4. Put that in my calculator. Comes out to 6. Looks like I'm on the right track, so I'm going to say C. All right, graph the write an equation for the in function notation for the relation graph below. So it looks like a straight line. That's a good thing. That's going to make life a little easier. Make a table of ordered pairs for several points on the graph. So they're actually going to write them out. So you weren't given the graph here. Hopefully this will be blank for you. So when I go to 1, it looks like it's 1, 1, 2, 4, 3 looks like 7, 4, 10, and we've got our kind of jumps up 3 every time and goes over 1. So that looks like it's going to be probably y equals 3x. That's what I'd probably think would start. Let's see what they say. The difference between x values is 1. The difference between y values is 3. The difference in y value is 3 times the difference of x values. This suggests y equals 3x. Let's double check by actually putting some things in. So if I put in x for 1, comes out to 3. That doesn't seem, that's not quite right. Well, I guess the first one is the y value for x is x. The difference is -2, so we're 2 off of what the original thing was here. Because when I put in 1, this says it ends up being 1. But here it says 3. So if I say the difference is 2, we're going to try some other values to see if we have the same occurrence. So when we put this in here, so 1, so if we put 2 in, if we times it by 3, it would come out to 6, and then 3. Times it by 3 comes out to 9. Oh, this one to here. Oh, that didn't give me what I wanted there. These here, it looks like it subtracts 2. These 2 subtract 2. These 2 subtract 2. So there's always 2 less than what 3x is. So I can probably write this as y equals 3x minus 2. That looks familiar, I bet. Let's see if that's what they put here. The pattern suggests it should be 2 subtracted, so check. Y equals 3x minus 2. 4, 7, looks like that's correct. Remember, they want this in a function. So function of x equals 3x minus 2. Now I'm going to show you something else that might help. When you looked at this originally, is there a y-intercept? Because we already know how to make these from y equals mx plus b. Well, we don't have b here. Does it start at 0? Well, it looks like if this line goes here, it's going to go down here. That looks pretty close to, see, these are in 2's. That looks like it's going to be at a -2. Now, you'd have to actually still go through the motions of actually trying some values there. So you still need to make this table of values, and you might not do it quite this way. Most of you will probably do, kind of a cross where you have x and y over here, and then you substitute in x for 3x. And what does y come out to? This is kind of a different one than we've used already, but most of us, we were used to going down like this. So, when x is 1, this would be 3 to the first. Y is going to be 3, but y is 1. So, yeah. Anyways, moving along. So, yeah, I would probably use that graph. If they give you the graph, use it, and use it how you know how to use it. Right, write an equation in function notation. So that means it has to have f of x in there for the relation that is graphed. All right, well, it's going up. I have there's a y-intercept of probably 1, since they didn't say it was anything else. So a y-intercept of 1. I've got a slope of rise over run, 2 over 1. So that'd be 2 over 1, or 2. So that's supposed to be a 1 there. So I can say a slope of 2 and a y-intercept of 1 would be y equals 2x plus 1. And to write that in function notation, it would be function of x equals 2x plus 1. Ta-da! And that's all she wrote.